Hello everyone, today let's solve the problem number 649, Dota2 Senate, right? So what the question states here, there are n senators in a circle, right? So just give me a second here, just remember this one, there are n senators in the circle, right? So 1 second, just give me a second here, let me change the color. There are n senators in the circle represented by a string senate, right? So there are n senators in a circle that is represented by string senate, represented by the string senate. This is fine. Senate of R and D, sorry, senate of this one, R and D basically. So I didn't read the full sentence itself. In turn order, each active senator either bans one opposing senator, right? So in turn order, each active senator either bans one opposing senator, nothing but removing them from all the future rounds, or if only their party remains, announces the victory, right? So in turn order, each active senator either bans one opposing senator, or if only their party remains, announces victory, right? So we have to return which party, Radiant or the Dia, will win, assuming all play optimally, right? What we need to return here, we need to return which party, Radiant or Dia, will win, assuming all play optimally, right? So this is what we need to do. So let me remove this one. Now let's do one thing, man. Let's go with the example one. So this one, right? So first thing, here Senate equals RD we have, Radiant we have, output is Radiant, nothing but the victory, right? So the first senator comes from Radiant, right? And he can join, he can just ban the next senators right in round 1, right? So this one, first senator is this one, R comes in the Radiant, and he can just ban from the next senators right in round 2. This one he'll ban this one D, right, Dia, in round 1, and the second senator can't exercise at all, right? So the second senator can't exercise any rights anymore since his right has been banned, right? So and in round 2, the first senator can just announce the victory. So see, this guy R will ban the D here directly, then he will announce the victory himself, since he is the only guy in the Senate who can vote, right? So this guy will win in that case. So in that case, what we need to return, we have to return the string Radiant, right? So if the winner was Dia, we have to this one, what we need to do, output the Dia basically, right? So same goes with example 2. Here on this case, Dia will win instead of the this one, Senator R, Radiant, right? So in this case, we have to output Dia, right? So this is fine, man. So this is the approach basically. So this is the question, sorry, right? So now it's easy to understand. They have given us wonderful examples just for the sake of understanding. Now let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code. First thing I want to tell you here is we will be making use of the greedy approach here. So again, we will be making use of the greedy approach here, right? So this is fine. So first step, we will be considering the first example. You can just try to implement the same thing in for the example 2. So now first, let's consider the index of the senators, man, right? So R is at 0, this one, and we have D as well, right, within the string. So D is at the 1, right? R is at the index 0 and D at 1. So we will put the positions of R and D within the 2 queues, right? So R will be put into the first queue, and D will be R will be put in the this one 0, and this one D will be put into the another queue, right? So here we will be putting the positions of R and D in the 2 queues basically, right? So round, let's see the round simulation here. Nothing but we will be making use of the greedy here again. So we will be making use of the greedy. So let's see the round simulation here. So we will process the senators by increasing the index. Each senator bans the earliest opposing senator still available. This is simple, man. So for RD, we have R0, right? So for RD, we have R0 that acts before D, that is 1, right? So R will act before D as R comes first here, right? So what we will do, we will remove the D. We will completely remove the D, right? So only R remains here. Only R remains here in this case. So only R remain here himself. So R will this one announces the victory basically. R announces the victory himself, right? So here in this case, whenever we have a victory, so what we will be this one outputting basically, when R wins, we will be outputting gradient, right? So this one we can, in the code, we can just include it in the by making use of the ternary operator at the return on something, right? So this is fine. So here the output that we got is radiant, which is equivalent to the output that they have shown for the example one within the question, right? So our approach works absolutely correct here. So what is the greedy idea here? Always let the earliest available senator ban the earliest opposing senator, right? So this is the greedy idea, right? So this maximizes that party's surviving order and mimics rounds, right? Basically, again, what's the greedy idea here? Always let the earliest available senator ban the earliest opposing senator. This maximizes that party's surviving order and it also mimics the round, right? So that's what we did here. So R0, he comes before D and D is at the place 1. We have placed both in 2 queues. So R is 0. So this guy can ban this guy D. So he completely bans this one and he himself this one, what do we call, announce the victory, right? So this is fine. When R wins, we have to go with this one, output the string gradient. So that's what we have done. So the output that we have got here is equivalent to the output that they have mentioned for the example one within the question, right? So now as we are familiar with the approach, let's do one thing. I insist you to try out the same thing for the example 2. You will get the output diamond, right? So they have given RDD, so you can just try to implement the same, right? Simple, very simple question basically. Now as we are completely familiar with the question, let's do one thing, man. Let's quickly discuss the complexities and then let's write the code. So what will be the time complexity here? We are going with the greedy, quite obviously it is big of n, right? So the time complexity here would be big of n, because each senator is enqueued or dequeued a constant number of times across the simulation, right? So total work is linear in n, right? So overall time complexity would lead to big of n. So what would be the space complexity here? We store up to n indices across 2 queues, right? So overall space complexity would be big of n as well, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. Now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So what will be the I think we have to create the 2 queues, right, just to store the indices of active gradient and the dia senators accordingly with the approach that we just discussed, right? So I'll just go with the dq here. So both are of the type integer, right? So this one, both in the sense, so why this is not taking capital I, man? Yeah. R equals, this one is for the radiant, new array dq. So this is fine. Let me copy the same thing and make the necessary changes here for the d. So all I have to do is change this one variable name to d. This is fine. Now this is just for the q for indices of r, and this is nothing but line number 4, q for the indices of d. Now we'll be making use of number of senators, this one, total number of senators multiple times, meaning senet.length multiple times. So I'll just assign this one to the variable n. So this one will be senet.length. This is fine. Now let's do one thing. Let's go with the for loop, meaning let's populate the queues with the initial position. So I'll just go with for here, int I equals 0, I less than n, I plus plus. So within the for loop, what I'll do, I'll just go with char c equals senet dot char at, so this one will be I. So if r, then add its index to the r, meaning if c equals r here, this is fine, r dot add last of this one I, this is fine. Else what we will do, I'll just go with d add last of, let me pass the I. This is fine. So let's do one thing. So first we are iterating through all the characters. So we are just getting the character at the position I. If R, then we are adding its index to R. If D, then we are adding its index to the D. So that's what we have done here within the loop, right? So now we have to simulate the process greedily until one party has no senators left, right? So let's move on with the while loop here. So this one, while not of R dot is empty. So this one ampersand not of D dot, oh, this one has to be is empty as well, right? So this is fine. So now within the while loop, what we'll be doing, so we have to take the earliest radiant index as well as we have to take the earliest dir index as well. So this one will be int ri r dot remove here. This is fine. So let me go with the remove first. This is also fine. And int, so this one di equals t dot remove first as well, right? So this is fine now. Now let's go with a simple if condition here, meaning so if the radiant senator acts before dia senator in this round, then radiant bans the dia senator, meaning radiant survives and will act after this one, right? So we have to articulate the same thing in the form of code. Also, if the dir acts before radiant, then dir bans the radiant senator and survives to the next round, right? So we have to re-enqueue dir at position di plus n. Initially we have to re-enqueue radiant at the position ri plus n, meaning radiant will move to the next round. And here if dir acts before the radiant, then we have to re-enqueue dir at the position di plus n, meaning dir moves to the next round, right? So whoever acts first will move to the next round, basically, in simple terms. So that's what we have to articulate that one in the form of code. So this one will be if ri less than di, then I'll just go with r dot add last. So this one will be ri plus n. This is fine. Now else what we need to do, so I'll just go with d dot add, so again I have to go with the add last, right? So this one add last of di plus n. This is fine. Now we are done with this part of the code. Now we are left with only one thing. So if the radiant queue is empty, then the dir wins, otherwise the radiant wins, right? So we can just make use of the ternary operator and we can just give this one within the strings, dir or the radiant, according to the question. So this one I'll just go with return r dot is empty here, sorry, is empty. So this is fine. So let me go with dir, else let me go with radiant. This is fine. Yep. So if the radiant queue is empty, then dia wins, otherwise radiant wins here in this case, right? So this is fine, man. Let me format the code once and let me hit the run button. I hope this works. Let's see. So I can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed, means the code works absolutely correct in this case. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.